All right, now the polynomials test review part 3 that I'm covering in this video. I'm going to kind of just cherry pick some of these questions. I don't know exactly which ones I'm going to do yet, but I'm just probably going to do a little bit of each, one of each sort of thing. So I'll start with factoring, just to kind of remind you of different types of factoring and how they work, but I probably won't do all of them, and we'll just see how it goes. Okay, we'll see what I have time for. Let's begin with, I guess, number 1, right? Difference of squares. Let's remember how we work difference of squares problems. I told you what it was, but you're going to have to figure out what difference of squares problems are without the labeling. This is a difference of squares because I've got a minus sign, and x squared is obviously a perfect square, and then 16 is another perfect square. When I have these, what I'd like to do is I sort of just branch them off. X squared is made up of an x times an x. And 16 is made up of a 4 times a 4. Now, one of these is a negative 4 because it is a negative 16. So when you have those pairs, then you just kind of match them up. So pair an x with a 4, and that's going to be an x plus 4. And then you can pair the other x up with the negative 4 and make, x minus 4. And then that's your final answer, x plus 4 and x minus 4. Now, I'll do the grouping one. I'll do number 3. There's another product and sum one that I'll do later on, but I want to do at least one of these grouping problems. So number 3, to factor by grouping, first, you're only going to use this when there are 4 terms. There are 4 terms here. To factor by grouping, we're going to group the first 2 terms together and then the last 2 terms together. Now, that negative is going to be a part of that 6x, so I'm going to make sure I include it inside that group. So with the first group, 2x squared plus 7x, I want to figure out what these 2 terms have in common that I can divide by. And they both just have an x, is all they have in common. So I'm going to take an x out, and I'm going to put that out front. Now with the x taken out, I'll still have 2x left in the first term, and I still have 7 in the second term. But now I want to know, well, the second group, what do they have in common? And it's kind of tricky, but these are both negative. Let's first start with that. But they're also both divisible by 3. So I'm going to divide by negative 3. And just like I did with the x, I'm going to put the negative 3 outside this group. All right, now let's see what's in the parentheses. So negative 6 divided by negative 3 will become a positive 2. There's still an x. And negative 21 divided by negative 3 is a positive 7. So at this point, you should notice something. You should notice that these 2 groups have the same binomial factor. They both have 2x plus 7, so that 2x plus 7 is going to be part of the next factored step. All right, and now what's on the outside? What's on the outside is x and minus 3. That's going to make up the next part. X minus 3, and that's it. If there's more that can be done, there might be. Like I think in number 4, you're going to have the difference of squares problem to do after you factor by grouping, which is why I've labeled it as such. But in this case, there's nothing left more to factor, so I'm done. Now when it comes to the sum or difference of cubes, you'll have the formula. You need to remember the formula for it. I'm just going to do, I guess I'll do number 6, I guess. Yeah, we'll do number 6 since it seems harder. All right, the sum of cubes. Now, this is going to be a little different than number 5, but the sum of cubes, its formula is, if I remember correctly, it's going to be a plus b, and then it's going to be a squared minus a, I think it's minus ab, and then plus b squared. All right. Yep, pretty sure that's correct. All right, so all I got to do is establish what A and what B is, and then I can just plug them in. We're good to go. So A is going to come from our first term. Now, these are 2 perfect cubes squished together. 8 is a perfect cube, and 8 comes from 2 to the 3rd power. So 2 is the cube root of 8. That's going to be part of my A value. Now, for x to the 6, a little shortcut is you since we're talking about cubes, which is powers of 3, divide the exponent by 3, and that'll tell you the exponent that you're going to use for the a value. So in this case, it'll be x to the 2nd power, because 6 divided by 3 is 2. So that x to the 6, its cube is x squared. And then for the b value, so again, this is my a value. I'll keep it in red. I'll put the b value in blue. We'll keep it that way. So the b value comes from 27. And 27, what's the cube root of 27? It's 3, right? Because 3 cubed, or 3 to the third power, is 27. So now everywhere I see an A, I'm going to put 2x squared. And everywhere I see a B, I'm going to put the 3. I just want to clean this up and make it look kind of colorful. All right, so I see A, so I'm going to put 2x squared here. And then I see B, so I'm going to put plus 3. And then for the second group, I have A squared. So in this case, I'm going to have 2x squared squared, right? I'm putting all of A in, and then I'm squaring it. And then I have minus A again, so I'm going to have minus 2x squared, but I'm also multiplying this A with a B value. So B is 3. And then we've got plus B squared. So B is 3, so we're going to have 3 squared. Now, it might look a little messy, but we can clean it up. So the first part, 2x squared plus 3, is still going to be 2x squared plus 3. There's nothing to simplify there. But when we come to the second set of parentheses, 2x squared squared. So what we're doing is we're squaring both 2 and x squared. So 2 to the second power is 4, and x squared to the second power is x to the 4th. And then for the middle terms here, 2x squared times 3, well, 2 times 3 is going to be 6. So that's going to be minus 6x squared. And then 3 squared at the end is going to be plus 9. So there's our final answer. The hard part really is not the plugging in. The hard part's knowing where the A and B come from and what they are. But it is kind of tricky sometimes to simplify correctly. You want to make sure you can simplify correctly. Because that is, of course, very important. Now, I'll do number 7 because it's a long product and sum method, and we got to kind of... Now, this whole method will work for any problem, any product and sum problem, but it doesn't have to be used on every single one, but it has to be used here. So, when it comes to product and sum, it's called the X thingy method, as some people refer to it. So, I'll put the X over here. So, the X is going to be... set up like such. So the top part of it's going to be your A times your C. Now for us, A is going to be 3, B is going to be 8, and C is going to be 4. So A times C will be 3 times 4, and that's 12. The B value is 8. So now I've got to solve this puzzle. The top number is my product, and the bottom number is my sum. So what two numbers, something times something, will multiply to 12, and the same pair of numbers added together will add up to 8. So what two numbers multiply to 12 and add to 8? And the answer is 6 and 2. 6 times 2 and 6 plus 2. So 6 and 2. But the trick is that these are going to become x terms, 6x and 2x. And they're going to be used to replace the original x term, which was 8x. So let me write this out. Our original problem was 3x squared plus 8x plus 4. But now what we're doing is we're replacing this 8x with 6x plus 2x. So we're still going to have 3x squared, and we're still going to have plus 4. But in between them, we're going to be putting in the plus 6x and plus 2x. Now, it doesn't matter which order you put them in. You could put the 2x before the 6x. That's fine. But now we have our 4 terms. We're going to factor by grouping. So group the first 2 and then the last 2 terms. So 3x squared and 6x. What do they have in common? They're both divisible by 3, and they both have an x. So we're going to factor 3x out. All right, and when we do that, we'll have x left and then plus 2. And the second group, both of them are divisible by 2, so we'll take the 2 out. And we've got what? X plus 2 left over. So just like before, the other factor by grouping problem, we have a common factor of x plus 2. So that x plus 2 we're going to bring down. And then we have to mention, well, what's outside those groups. We have 3x on the outside and plus 2. So together, 3x plus 2. All right, and that's it. We're done factoring. When it comes to solving, it's the same thing as factoring, but you have to set them equal to 0. So like for that last one, what was it? We had x plus 2 and 3x plus 2. We would set them equal to 0, and then we would solve each part. So it's easy when it's already factored, like number 8 and number 9, because you just take each piece and you set it equal to 0 to solve. So I have x plus 5. I'm going to take x plus 5 and individually set it equal to 0 and solve. So if I had x plus 5 equal to 0 and I solve it, I'm going to have x equal to negative 5. So that's part of the answer. And then we'll do the same thing for x minus 11. X minus 11 equals 0. You're going to solve it by adding 11 to both sides. And we're going to get x equal to 11. So there's your two answers. X equals negative 5 and x equals 11. You're going to do the same exact thing in number 9. You'll have 3x equal to 0, and you can solve that. You'll have x plus 5 equal to 0, and you'll solve that. And then 2x minus 3 equal to 0, and you'll solve that. But I'll let you guys solve this. Number 10 and 11 is factoring. So you got to factor them first. So number 10, factor by grouping, since there are 4 terms. Group the first 2 terms and the last 2 terms together. And then number 11, use product and sum. But when you factor it, make sure you set each piece equal to 0 and that you solve them. So for number 12 and 13, I'll just do one of these. But it's asking, is it a factor? So we're going to use synthetic substitution, which is kind of like synthetic division, where I have the box in the top corner. So we're going to have a box here with my a value. Now my a value comes from this. In this case, it's going to be negative 5. Remember, we just talked about this in the last video. But it's always opposite. The a value is from that. So it's a negative 5. And then I put the coefficient of my polynomial. So I have 1 for 1x to the third. Then negative 2 for negative 2x squared, negative 25 for negative 25x, and then 50. So all we're going to do is work this out, and then if the remainder is 0, the answer is yes, it is a factor. And if the remainder is something else besides 0, then it's no, it's not a factor. So let's work it out. Let's see if the remainder is 0 or not. So we're going to bring the 1 down. We're going to multiply it to negative 5. 1 times negative 5 is negative 5. So negative 2 minus 5 will be negative 7. Negative 7 times negative 5 will be a positive 35, which with negative 25 makes a positive 10. And then 10 times negative 5 will be negative 50. And when you add them together, 50 minus 50 is going to be 0. So my remainder is 0, which means yes, x plus 5 is a factor of that polynomial there. So you're going to do the same thing with number 13. Just look to see if the remainder is 0. All right, I'm going to shrink this down a little bit. Let me move this over here. All right. So I'll just do this one graph because the next one's very similar to it. But even or odd, that's the question here. Even functions means that both ends go the same direction. Now, both ends here are going up. So because they're both going the same direction, this is going to be even. Now, is it positive or negative? Well, for even functions, if they're both going up, it's positive. If both ends are going down, it's negative. Now, both ends are going up, so this is positive. Now, the degrees kind of, you guesstimate this based on how many curves you have. Now this is just a U shape. So it looks like a quadratic. Quadratics have a degree of 2. Now that means that this has 2 roots in total. Remember, these should always be the same, the degree and total of roots, because of the fundamental theorem of algebra, which says that the total number of roots is the same as the degree of a polynomial. So those should always be the same. Now, of those 2 total roots, how many are real and how many are imaginary? Now in this case, you have, the real roots are always x-intercepts. And in this case, I have 2 x-intercepts. So that means I have 2 real roots. Now, if I have 2 roots in total, and 2 roots are real, then that means there's no roots that can be imaginary, right? Because the total roots would equal the real ones plus the imaginary ones. But if I have 2 in total, and then 2 of them are real, that means there's no imaginary. Now for the end behavior, I'm going to have to erase that equation I put at the bottom just now. But for the end behavior, so I have room. The end behavior is about which direction the graph is going. So it's even and positive. So let's take a look at the graph. So as you move towards the left, and I understand that the function is completely on the right side, that's not the part that matters. The part that matters is just the direction. So for the left side of the graph, as the graph moves left, right, that's talking about as the x is going towards negative infinity. Right? As you're moving to the left, as your x-axis gets closer towards negative infinity, the function, yes, it's not all the way on the left side, but it is moving left. The function is going up, which means our function f of x is going towards positive infinity. It's going up, so it's going towards positive infinity. Now we'll do the right side. So the right side, as the function moves to the right side, which means as x is approaching positive infinity, right? Because if you're moving this direction to the right, you're going towards positive infinity on the x-axis. As you move to the right, the function's going up on that side as well, which means the function is going towards its positive infinity too. So there's your end behavior. I'm going to end this video here, guys. I hope it was a little bit helpful. You know, like I said, I kind of cherry picked, so I didn't go over everything, but I went over all the main things. Everything that I showed you is in some way, shape, or form going to be on the other problems that I didn't. There's nothing that I skipped over, at least as far as I know. Maybe the difference of cubes, but it's very similar to sum of cubes. All right, guys, like I said, I'll end it there. Good luck on your test. Please stay after school or come by during homeroom if you can to get some help. Okay, use this for test corrections as well. All right. I'll see you, I guess, later. Good luck on your test, folks. Bye-bye.